Let's have a look at completing the square for this equation here. Now, in this case, if I'm going to complete the square, I would normally do it slightly differently. Now, in the previous example, what I did was I completed the square first just for the expression x squared minus 3x minus 18. We didn't have an equal 0. I wasn't concerned with that. And then at the end, I said, oh, let's now complete the square, made everything equal to 0, and solved for x by making x the subject. Let's do it differently now. This is what I'm going to show you is quite a common approach. And this is actually my preferred way actually of doing this. So notice in the last way when we did this, we went ahead and we added the b term to each side and we subtracted the b term from each side. It's all on one side there. There was no equal 0. Now let's do it slightly differently. So now I'm going to go ahead and I'm going to say that implies that x squared minus 3x. I'm now going to add 18 to both sides. Here it is, plus 18. There it is, 18. And now I've got a space here. And in that space, I'm going to take the b term, which is negative 3. So I'm going to add negative 3 over 2, square it. Now, previously, if it was on the same side, I'd then subtract it from that same side. But now I'm going to add it again. But because I'm adding it to both sides, it's now balanced. It's still true. In other words, as in any algebra, if we do something to one side, we do exactly the same thing to the other side. So I'm going to add negative 3 over 2, and I'm going to go ahead and square it. So this bit now on the left side, the left-hand side bit now, that bit there, that expression there, is my completed square. That's x. I'm going to take the minus 3 over 2. I'm going to put a square. That is now the completed square. And on the other side, I've got a whole lot of other stuff left over. So I've got an 18, and I've got a negative 3 on 2. Let's have a look at that. So I've got an 18. I'm going to add, well, 3 squared is 9. 2 squared is 4. So I've got 18 and 9 over 4. Well, from the last one we saw, we got 18 and 9 over 4. That's actually equal to, 81 over 4. So I've got my x minus 3 over 2, all squared, is equal to 81 over 4. Now I'm going to find the square root of both sides. And to do that, I'm actually going to shift this over a little bit because I don't have the room I need to do this properly. Again, this is a planning thing on my part. I really should pop this over a little bit more because I'm going to find the square root of this side, find the square root of that side, so it's going to be plus or minus. And you'll see we end up in exactly the same place. So now I've got an x minus 3 over 2. This is now the square root and the square have cancelled each other out. Square root of 81 is 9, and this is going to be over square root of 4 is 2. Now I'm going to add 3 over 2, add 3 over 2 to both sides, add 3 over 2 to both sides. Of course, negative 3 over 2 and positive 3 over 2 is 0, leaving me with an x. And now I'm left with a 3 over 2 plus or minus a 9 over 2, which is the same as saying 3 plus or minus 9 all over 2. And as you saw before in the previous example, we're now able to solve for x. And 3 plus 9 is 12, divided by 2 is 6. So we can say either, and the either or bit's important, either x is equal to 6, or we can say x is equal to, I've got 3 minus 9 is negative 6, divided by 2 is going to be my negative 3. And that is my solution. So one way was simply taking the expression, not worrying about the equal 0, adding the b term and squaring, adding the b term halving and squaring it, and on the same side, subtracting, adding, and squaring it. When we do it where we're using both sides, as we have here, because we do have another side here, we're able to do it slightly differently. And here we're adding it to one side, and we're going to add it to the other side. We're adding it to both sides. So that's just another approach of doing it. We end up in exactly the same place, as you can see. And in fact, this is my preferred approach. So I can kind of keep the two things separate. And this is my completed square here. And then I'm going to work out what the thing's going to equal. Hope that makes sense.